So hi guys, in the previous video we have learned about simple list, runtime file, custom editor, type of payload types. So in this video we will be learning about character substitution, case modification, recursive graph. So starting with character substitution. This payload type lets you configure a list of strings and apply various character substitution to each item. It may be useful in password guessing attack for generating common variation on attack dictionary attacks. This UI lets you configure a number of character substitution when an attacker is executed. The payload type works through each of the configured list item in turn. For each item, it generates a number of payloads to execute to include all permutation of the substituted character according to the defined substitution. For example, this is the example of Peter. So we will be using the live example. Okay, let's move on to Burp Suite. So let me show you. So first of all, let me show you what is the character substitution. Some of people can be confused in this one. So let's suppose you are a hacker and some of the hacker use their hacker word as a hacker. Okay, CK37 sometime. Okay, like this one or someone like this. So why people are using 4 here? Because it's just a swaggy name. But sometime think about like you get a sneak peek of someone's username. That username is related to hacker. So you want to see, is there any chance that it can be similar to like this or anything like he can be using 4 as here and CK3R, because this is upside down 4. Sometimes the people think about like this. Okay, so you want to do this type of character substitution. You want to change A into 4 and E into 3 and 4 into 7. So these things called character substitution. So we are trying to do the same attack with the help of character substitution payload type. So a majority of people who are like there can be a thing like someone is named. So let's move on to Burp Suite and let's see what we can do with the character substitution payload type. So here is the example. I have named this. I have a request from the mintra.com and I named this lecture for this lecture, and I have selected the auto thing. Okay, I just clear and I will show you. This is the auto selection. Wait, sorry, I think there was something wrong here. So this is a auto selection. We are using character substitution here. Okay, so let's see what is there. So as I told you in the example of hacker, so there are some people who used to be like this. Okay, so I have changed like A into 4, B into 8, so and E into 3. So you can see there is no B in hacker, so that's not the use of this one. So what I will do is I will just clear this and check something related to hacker, that words that simulates something around it. Okay, so let's suppose someone can change C into, okay, I never seen. Okay, let's see if K into, okay, suppose let's see K into 6. If someone have password or username, you might think like he can change his K into 6, or there is something like this. If someone is using his username with his date of birth, okay, and you don't know his date of birth, okay, or you don't know where he used that date of birth, so you can use the character substitution to change his first word with the last word and last date of birth with the first ones. Okay, so there can be combinations and permutations. You have to think about your example first. Okay, so that's the case of your thinking. It's on you that you want to, how you can create that example in your mind and execute that. Okay, by default there are 16 places you can change, like 4x4 16. So also you can change like case sensitive words. Okay, so this is same as simple list. You can just paste, load, remove, clear, add. Okay, also you can add from the list. Okay, if I add something from here, okay, this is also, but I just want to add hacker here. Okay, so that's not a problem. So let's start. So as you can see, the payload count is 8 and request is 40. So but the thing is approximately, because they don't know how many permutations will be created with this. Okay, so let's see. So our attack is starting. Sometime Myntra.com takes some time to launch the attack because they're Akamai WAF and they don't allow the requests that much fudging like things. I have already tried these things, so there can be error. Okay, I think it's showing error, something like this. Okay, so let's see, we have some other request in pocket. So we are on HTTP history. I have already selected. Okay, what about Google one? Okay, this one. Let's see, let's try on this one. Name this on test. Okay, and clear everything, and we will try to change something here. Okay, and our example will be new here. Okay, this is by default. So what I will do is, okay, I'm not changing something. First I will write Google here, Google. So Google, like this one. So uh we don't have, I will delete everything that is not related, or let it be because it's not related. So I will change like big G into O. G, okay, there can be O into 0. Okay, also I will change E into 3. There, it's on my mind. Okay, there's nothing like this one. I just changing these things from with my mind. Okay, I'm not guessing something like this. Okay, so I will delete everything that is not related to I will change L with the 1. Okay, I will change L with 1. I will delete this one. Okay, so let's delete these things that are not related to us. Okay, let's see and let's try the attack now. And also the big G into someone may change it into 8, I think, I guess so. Okay, let's see the attack. Okay, as you can see, they have changed G into 6. Okay, they first tried G and then search here and it was 6. Okay, then they tried G's, uh, this was simple request, and then they tried G into 6, and then they 1 O into 0, and then 6 0. Okay, this was going on and they were trying everything. Okay, so if we think about the big one, this is also changing, this G is also changing into 6. You can see this G is also changing into 6. Why this is not changing 8 here? Okay, because G is G. Okay, you can't, if you click on here case sensitive match, then it will be something else. Okay, let's see now. Okay, let's see if we are able to change that G into 8. Now you can see that G is changed into 8. Okay, so now we are successful. We are using case sensitive match. Okay, so that's how you can use character substitution payload type in Burp Intruder, and there can be lot of possibilities. You just have to think about your example and your case. Okay, that's on you. Okay, so let's move on to the next one. So next one is case modification. This payload type let you configure a list of strings and apply various case modification to each item. This may be useful in password guessing attack for generating case variation on dictionary attacks. Okay, let's think about this. Someone name is hacker. Okay, username is hacker, but you can think like he can be using the first H. Okay, let's see on notepad. Okay, so someone username is hacker, so maybe he can be writing hacker like this one or like this one or something like, it will be all lowercase. Okay, we already have lowercase. So, and if someone is like hacker pro, so he can be using like hacker pro or hacker pro or hacker pro. It's not changed, so I delete this one. Okay, so it can be like hacker pro, say, with this big one. Okay, so there can be chances of making, he can what else he can make, let's think. Okay, I think he can make something more interesting, like if you see, I can have a sneak peek in the example section. Okay, so that's the cases with the hacker. Okay, so he can write in all lowercase first word in first character of every word with uppercase, then all uppercase, and then the proper name in the uppercase. Okay, so let's see this one. The similar thing is used in case modification. Okay, the following case modification rules can be selected in case modification. No change, the item is used without being modified. To lowercase, all the letters in the item are converted to lowercase. Uppercase converted to uppercase. The proper name, the first letter in the item is converted to uppercase and the subsequent letter are converted to lowercase. Okay, the first letter in the item is converted to uppercase and the subsequent letter are not changed. Okay, let's see this in. Okay, so this was the example with by PortSwigger. So let's see in the burp intruder. Okay, so we are already on this request, previous one. So let's move on to the case modification. Okay, so this time we are also using Hacker Pro. Okay, first I will use Hacker, then I will use Hacker Pro, and Hacker Pro I will write me Hacker Pro. Okay, there can be a chances someone writing me Hacker Pro. Now let's see that what will happen now. Okay, so as you can see, it was not changed. Then first letter is uppercase, then all the uppercase, then all lowercase, then first one is uppercase, first one is uppercase, and the second word is lowercase, starting with lowercase, and then all uppercase. Okay, and the similar is in this one. So that's about the case modification. You can use this in if auto generated names are there, like some names are generated auto generated, so someone have like name, like my name Prince Sharma, so I'm using the print with p upper p, and maybe I'm using all uppercase lowercase. So these things can be used for guessing the username, passwords, and these things. Okay, so that's about the case modification. Let's move to next one. Okay, so the next one is recursive grab. So first of all, what is the recursive grab thing? Okay, I'll show you something. If I start this one and you can see this one, and if I click here and I click on grab extract. Okay, so this is a like the grab function, it collects the pattern from somewhere. Okay, so the grab extract is a function that will extract something from that response. Okay, so let's fetch some response and let's see something. Okay, so let's suppose I want to check what will be here. Okay, I want to check what will be the key content length. Okay, I want to check the content length, like it's important. In some request you are changing there. Okay, so let's see the request, let's see the result. You can see a new column here with length written here. So it's the grab function is extracting that content length from every request. Okay, it's using that grab functionality within the burp attack and trying to extract that and made a column. Okay, so that's the thing is recursive, that's a grab thing. Okay, so let's move on to the recursive grab. What is the recursive grab in this payload type? This payload type lets you accept each payload from the response of the previous request in the attack. It is useful in the some situation where you need to work recursively to extract useful data or deliver an exploit. Okay, the payload type works together with the extract grab. We already learned this. Now function which is used to extract part of a response containing interesting information, the text that was extracted from the previous response in the attack is used as the payload for the current request. This can be used for various tasks. For example, it may be possible to extract the content of database by SQL injection by recursively injecting queries from the form. Okay, so like this one, this is a SQL query and they are trying to get the value a from the previous error. Okay, so something like this one. Okay, so this case or this example is very specific. Okay, so if you want to use these type of payload types, your example will be specific according to that, or your thinking should be you have to think outside the box to implement these type of things in your request, or else you are just using the simple list. Okay, so that's why try these with the simple example and try to think if in your case there can be example that you can use these things. Okay, then the query is then repeated using accounts to identify the next object. Like the next object is trying this one. Extract the following option must be selected. Extract wrap item from which to drive payloads. This is extract wrap item will be used to drive the payload. Initial payloads for the first request. This is payload to use in the initial request where no prior response is available to drive the payload. Okay, you can't just select the extract wrap from the first request. You have to set a initial payload. So after that, after executing that initial payload, then the response from then something from response can be extracted and you can put that into the next payload. Okay, stop if duplicate payload found. It will stop the attack if the payload is duplicate. Okay, note that because of nature of this payload type, attack using it must employ a resource pool with a max concurrent request of 1. Okay, so let's see this. So first of all, I will just choosing the recursive graph. Okay, so let's see the initial, what will be the initial payload. Initial payload with the hacker. Okay, and so I know I have to change this into 1 because concurrent request should be 1. Okay, concurrent connections should be 1. And let's see on the extract, I will just add something from here. So what I want to change, I want to change that time. Okay, because it can't be, I think this can't be. Okay, let's see if I just change this one. Okay, and what about only changing the seconds, because set seconds will be changed but minutes will not be changed. Okay, I will just use this one. Okay, and let's see in the payload, you can see it here. The first payload will be hacker, and then the, okay, let's start the attack, then you will know it properly. Okay, so position is already selected, and let's see. Okay, so first one was hacker, and then there's nothing. Okay, why there is nothing? Because okay, 09, I think there should be 09 here. Why it's not putting 09 there? I think it can't put the 09 there. Okay, let's see something else. Okay, I think there may be some issues with this. Let's remove this one and add something else. What should we add? Okay, I will add, okay, what about I just add this one, connection close, because it will be similar in every connection, and payload will be duplicate, so attack will stop after 2 requests. Okay, let's start this attack. Okay, so you can see we are getting this one. So when we are sending no payload, that's going good. When we are sending hacker as a payload here, okay, then that is checking the response and collecting this connection. Okay, connection that is closed here. Okay, and that closed word is used as payload. Okay, they are just using the payload word, and it will never stop this attack because attack is just going on. There is nothing, there is no limit on this. Okay, so if I just click on this stop if duplicate payload found, like the payload was duplicate always, close was always close. So now we have just stopped this request after 2 requests. Okay, so that's how the recursive graph thing works. In this, your, like, this example is not working here. We are just using a simplest example. I am using these simple examples to teach you these complex things. Okay, if you want to learn something, you have just my trick to learn something complex is like create a simplest example in your head and try to execute that. If you can create your own examples, simplest example first, you can create your complex examples or complex case scenarios. Okay, so that's how you can learn the new things. That was about the recursive graph. In the next videos we will learn about the illegal Unicode, character block, numbers, dates, brute forcer, null payload, character prober, bit flipper, username generator, ECB block shuffler, extension generator, and copy other payloads. Okay, that's all about this video. Thank you guys.